way to start off the game. And if I roll a 4, that's another pretty good way to start off the game. So you should wind up seeing that borne out in your simulation. And this is a good statement about how important intuition is when you're building up Monte Carlo simulations of whatever it is you're doing, because if you don't get a number 1 as your answer, at least for the first one, something's probably wrong with your code. What is the probability that someone who goes first will win in a 2 or 4-person game? And then optionally ask another question of your simulation and answer it yourself. Okay, so that's it for the homework. Any questions? We're obviously trying to get you using kind of the object-oriented paradigms that we saw today. I will also push this out over the webs, and your fellow classmates that decided to bail out will be docked 4 credits or something. All right, so are we all set to go? All right, so without further ado, I think I'll kill this back here. Let me introduce the last part of our day here, a very special panel. It is titled Python in Industry, and we have 6 wonderful people from industry who have very gracefully offered themselves and their time to tell us about what happens in their company and what they're seeing throughout industry in the context of Python. It's a language that hasn't been around for a very long time. Obviously, it doesn't solve all problems, but what I thought we would have you hear here today is just how it's being used outside the confines of academia. And maybe just start off this panel with asking everyone to give a few-line statement about themselves, where they work, and sort of how they came to Python, and then we'll sort of get the conversation going from there. So why don't you start? Charles?
Hey. Hello. All right. Hey, my name is Charles Covey-Brandt. I work at a company called Disqus. We do web comments online. We handle about 1 billion uniques every month. Actually, that number has gone up, but we handle a lot of traffic. I am a full-stack engineer there, and I came to Python at my last job at the Washington Post company, where we were doing a lot of our feature work and our web development work in Python in a framework called Flat. It was Pylons. We were in Pylons.
Hi, everyone. Is this on?
Yes.
Oh, okay. Sorry. I'm Ken Elkabany. I work at a company called PiCloud. We offer a cloud computing platform for high-performance computing, scientific computing applications. So actually, a lot of academics end up using our platform to do a lot of scientific work, and that tends to be in Python. But not only are a lot of our customers in Python, internally at the company, we use Python quite extensively to both prototype as well as build our platform to make it really easy for scientists just to effectively get a supercomputer at any point of the day to run their computational workloads.
My name is Clem. I work at GitHub, and many of you probably met me earlier if you listened to the lecture previously. If you don't know what GitHub is, github.com, you can go check it out right now. A website for collaborating on software and other various things, sort of based around the Git version control system and a very modern style of software development. I'm actually an electrical engineer by training, sort of came up through robotics and embedded systems. Been a developer at GitHub for many years now. There were less than 20 of us when I started working there. Seen the company grow to 10 times that size, and my role now is much closer to sort of corporate and product strategy than it is development, but I still do quite a bit of code. I actually don't write Python, and GitHub doesn't use a ton of Python. We have a variety of libraries and open source frameworks that we do use that are in Python, but it isn't really one of our core competencies. So I'll be the voice of dissent on the panel.
Hi, my name is Erin, LeDell. I am actually a PhD student at Berkeley in biostatistics, but I'm also working as a data scientist at a company called Wise.io, which is basically a company that has a machine learning platform on the cloud. So I've been using Python for a number of years, I think maybe like 8 or 9 years. And recently I've been using a lot of R, but now I'm sort of back into the Python world. And if you guys if any of you are programmers and you want to make the transition, you should really check out the Pandas library, which I think you've mentioned. But that's really what facilitated the transition for me, is being able to work with data frames in the sort of sense that I'm used to. So.
Hi, I'm Berian. So I was a postdoc here in the Department of Astronomy until around 18 months ago, and then I went through the Insight Data Science Fellowship Program, which some of you may have heard of, and ended up in a position at Square, where I've been working for the last year. So at Square, I'm basically a data scientist. We use Python pretty extensively throughout the company, so I think we'll have plenty to talk about here. Yep.
My name is Grace Law. I am actually an independent Python recruiter. I am also a organizer of the San Francisco Python Meetup. If you guys haven't known about that, we should go to the website and check it out. We organize monthly events for people, both senior folks as well as people that are getting into Python. And how do I get into Python is a very interesting story. It was actually in 2005, I worked for one of the former strategic advisor to the New York Mercantile Exchange, and he decided to have his own trading firm. And how it's going to make money is by spotting the discrepancies between the sell price and the buy price in different markets. And they find these discrepancies and then they execute the trade, and they make pennies off of each transactions, but they run hundreds and thousands of transactions a second. And they find that when they switch from Java to Python, they were able to make a lot more money. They literally rewrite their Python applications every 6 months just so that they can get their software run faster. And so I got really, interested in, wow, this Python is a very exciting language. It can really do a lot. And so since then I've also really enjoyed the people that I met in the industry, and then have decided to stay recruiting in the Python field.
Great, thanks. So I guess let me ask a question for, I'll start off with Berian. How central is Python to the work that you do at Square? And you said it's sort of used throughout. I guess I'm pretty interested to know, when we think about Square and we think about transactions, we think about this as sort of very low latency. How critical and how seminal and how useful is Python in a very sort of high frequency environment? Sort of ties to what we were hearing just now. Maybe you could just talk about that, and then I'll ask some others as well.
Yeah, I think this is a great anecdote. This really shows the power of Python. Should I just talk normally? Okay. All right. Okay. Yeah. So I think you will have heard that Python functions extremely well as a glue language, and that's something that we see over and over again in industry settings. It enables us to do things very rapidly, to prototype things very rapidly, and to understand and explore data very rapidly. And those things are crucial for making decisions, for building products. And so it's those kinds of flows that we go through over and over again as we're trying out new ideas and trying to create new experiences. Yeah. Great. What do you guys think?
Charles, what do you, tell me about the extent of this in Disqus.
Sure. Yeah. So at Disqus, we're on a web framework called Django. And we definitely use Python and Django as the glue between a number of other software technologies to help us sort of achieve that scale that we're at right now. And I think the thing that we definitely use Python for the most is getting features out very quickly. So we can iterate very quickly, we can change, we can implement business logic very quickly. And then in many cases, as that feature has lived for a while, we may transition that to something else, or we may keep it in Python. We may transition to a different technology. One example is we had a real-time event system that we had written in Python a couple years back, and the feature set for that had basically stayed stable for a couple of years, and at that point we said, well, it's time to actually change the technology to Go. So we switched to Go, but Python had helped us get to a stable feature set very quickly, which is great.
So Ken and Clem and Grace, in some ways you're all sort of facilitators of Python. You know, I assume that a big part of PiCloud is written in Python, and we just heard that a big part of GitHub is not. But you're all kind of making Python happen in an operationalized way, sort of in the back end. So maybe you could just talk about sort of where you see Python going. You know, actually just tell us where it's been and where you think sort of Python as a sort of industry tool is heading.
That's right. Okay, so I think one of the biggest benefits of Python, which is why we selected it, and one of the reasons why it continues to be extremely important within PiCloud, is just its versatility. So there are several languages that are kind of known for having specific kind of talents almost. PHP is very much kind of the old web framework kind of language. You have Ruby on Rails, which is kind of invented more for, once again, web frameworks. With Python, you have some pretty solid web frameworks like Django, but you also have all sorts of other tools, from data visualization to scientific computing, NumPy, SciPy, Pandas. There's just so many different things in the Python toolbox. And so as a company, you know, with PiCloud, we selected Python initially, despite the fact the team didn't have the most experience in it, primarily because we thought it would be the least limiting for the team. You know, when you want a team to have support multiple languages, you start having different levels of expertise, right, for each language. And so there becomes a transition issue for having a developer A move from one language to another. It's not that it's difficult. Most developers can do it. It's just there's a bit of a lack of comfort, a little bit of a switching cost. And so Python for us was so powerful because it allowed us to do everything. The web stack, the back-end high-performance stuff, the middle of the stack, database layer, all of that could be, if not written in Python, at least wrapped and glued together with Python. And so that's probably why, you know, we've stuck with it, and I think that's one of the reasons why it's such a large and moving force in industry and academia as well.
Tim, do you want to say something about sort of adoption, and if we were plotting derivatives of Python versus Ruby versus Go versus Julia, I mean, Scala?
I guess, you know, from my perspective, and maybe even GitHub at large, we tend to be really pragmatic about our choice of languages and tools. People talk a lot about GitHub being sort of a Ruby company or a Rails company, and those are certainly technologies we use, but I would maybe even consider us more a Unix company than anything else, as we really believe pretty clearly in some of those core Unix principles, and the reason we love Ruby so much and the reason that we often write things in C and in script and bash and stuff is we like that way of architecting systems, and it's scaled really well and functioned for us. And by and large, we sort of feel like you simply need to embrace some set of technology that is solving real problems for your business, and you need to do that in a pragmatic but not sort of these like religious or dogmatic ways, and that understand what the problem sets are and understand what your options and tools are, but then sort of dive in and embrace the constraints of that particular framework or those particular languages. We also write code, we write Objective-C code, we write C# code, we have Java in the stack, we have Go in the stack, we've written Erlang in the past, we actually have Python in the stack as well. We heavily use things like Graphite to collect metrics across all of GitHub. Internal applications. Pigments powers all of the syntax highly on the web. And so it usually just is sort of like, what's the best tool for the job and where do you want to be involved? The thing that I have loved most about sort of being cursorily involved in the Python community through IPython and Fernando is just, it's one of the best examples of a great functioning open source community on GitHub. And we have all these small communities that are doing things. And I sort of love it when one segment of the GitHub population takes off on its own and has sort of real clear motivations and directives. And so that, to me, that's one of the most important places, is finding somewhere to be plugged in, where you're going to learn and where people are solving problems that you care about and are using the tools and technologies that you want to work with every day, because that makes you happy as a developer and makes you feel like you're progressing.
One thing that I would sort of highlight there, which is interesting, and I think it's something that Disqus does as well, is we're not ever just saying that we're going to use Python, or like you're not ever just going to use Ruby. We are really looking at what tool fits the job and the business requirements. But we also do find ourselves using Python pretty frequently, almost for every feature that that we implement, we're using Python. And I imagine that in some ways it's the same for you with Ruby, that you find that there's a little bit of organizational knowledge, maybe a little bit of inertia with Ruby, and you know how to hire for Ruby. Is that?
Absolutely, and some of those things depend on who you want to help you with your projects. GitHub's very self-selecting in what you work on and what you do on a daily basis, and so if you want to go write your next project in Python, no one's really going to stop you, but you might struggle to persuade other people to build that particular thing with you, and so that's part of it as well. With sort of a lack of traditional management structure and a lot of sort of onus placed on the individual to take responsibility for their job. If you can't convince anybody to work on something with you, you might not have a project that's worth spending your time on. So,
I think that may be happening with us with a Windows Phone application.
So, Grace, maybe you can say a bit. You've helped a number of companies scale up with a lot of Python workers. Where do you see all this going?
So I would say if you are looking in Python, you are probably looking at a few different spaces. You're looking at writing web applications. You're looking at maybe helping with infrastructures, dealing with DevOps stuff. You are looking at handling data science, analytics stuff. And then in each of these sector, there are different companies that are hiring for people. Let's say if you're interested in consumer space, there are that's like very much web app stuff. If you're interested in working with very high transaction software that has that deals with data, you might be looking at companies that are dealing with figuring out how to retarget ads. If you are interested in healthcare and bioinformatics and so forth, there are at least like 4 companies in the Bay Area that would want to have your Python and skills to look at data. So there's like a lot of different things that you can tap into, and I can't believe I forgot to like mention cloud services as well. So testing is another area where people like to use Python to write a lot of tests as well. So there. I want to echo like Ken's comments. It's really versatile. You can really use Python to do a lot of different things, and then once you find your specialization, then you can go a lot further and learn a lot from your peers.
Great. So Erin, we have in the audience here and in the bootcamp in general a whole bunch of academics who are either undergrads or grads or many postdocs, who are used to sort of building up sort of research programs and getting sort of scientific results. You come from that world, and now you're sort of applying skill sets learned in that world to the business world. Maybe you can talk about how that transition has been. You already talked about how you sort of were using R, now using Python, but how does somebody who's learned to build some of these great scientific projects and results, how do they translate that into the kinds of things that we just heard about from Grace that are really in high demand?
Well, I guess I could say, so for a long time recently I was using R to do a lot of stuff, and I was put in a situation where I was doing some consulting, and they needed to basically take the models that I wrote and put them into production. So one thing that Python is really good for is it has a lot of APIs to sort of connect to other languages. So there's a Python package called RPy, which basically lets you run your R code and connect, basically open up a session and do everything in there. So at first I was kind of sort of teetering on that boundary of using Python to do, write maybe my database queries over here through some sort of other API that's talking to a database, and basically the glue concept was coming up a lot. And I guess I just realized that I didn't really need to add this sort of overhead of writing in 2 different languages anymore. I could just basically, with some work and some time, move what I'm doing into Python and basically make it a lot easier. And so, if you're just getting used to Python and you're comfortable in another language, you should take advantage of the APIs and sort of, gradually move in and see what you can, maybe write in native Python, and sort of a nice transition process.
Can I ask you a question? I'm interested in terms of collaboration.
Mm-hmm.
Have you found a difference between some of the research tools you were using before in Python?
You mean in terms of collaboration, like open source?
On the code itself.
Yeah, well, so one of the reasons that I still use R a lot is because a lot of people in statistics use R. So for that purpose, I sort of am constrained to using R a lot. So, however, in all other worlds, other than the statistics world, most people are using other languages. So it's easier for me to use Python and stuff like that. So I guess it's great if you can know more than one language, but you sort of have the ability to adapt to whatever is around, and it's easier if you even just if you know a little bit of Python or a little bit of R to, did that answer your question?
It did a little bit. I was also interested. Do you have when you're working in a research capacity, are
Mm-hmm.
you mostly writing your own code, or are you like collaborating
see.
through a code repository or a code versioning system like GitHub?
I'm writing my own code and I write my own packages, but I also use a lot of other people's packages, like in any language. So R and Python have kind of a similar, they both have really good communities in terms of software being available and easy to download and relatively easy to install. So, yeah, I guess, I don't know, does that?
I was asking because one of the advantages that I see in Python that's really interesting is that when you are actually even collaborating in the same code base, that the way that Python is structured really helps you work with more than one person at once. The white space is great for comparing lines. The modularity I found is great for collaboration. And I don't know if that's the same, if that has an equal in sort of like the research side, or if that's very different, if it's tough to collaborate on the code itself.
Yeah, I would say that in general Python there's more of, they always talk about the Pythonic way of doing things. So there's sort of maybe more established conventions of, you have a main in your file, then you have your other functions here, and maybe you can import like another module. There's more of a community-driven ethos of how to do things, and it makes it easier to share code, whereas in R maybe, or even some other languages, it's more of just I don't know, just a free-for-all from what I've seen. But, that could just be my experience.
So I want to take a quick pause here and just make sure that the audience, I didn't say this explicitly, but I'll be explicit now. If you have questions, please just raise your hand and pipe up, because this is really for you. Yes, we have one over there.
Also for Erin. You were able to do all your modeling in Python?
I'm just going to repeat the question. Erin, were you able to do all your modeling in Python?
There are certain models that have not yet been exported to Python, but they're things written by my advisor. So it's non-traditional things. So they're written in R and whatever. But but that's something that if I wanted to do, I could do. It would take some time. But for the most part, in terms of machine learning, there's a lot of stuff available. So that's what I do. So for me, it's okay. Yeah.
Someone else want to react to that? Any other questions? Yes, we have one there.
Just being from a totally academic setting and not really an expert in any one computing language, but I think probably a lot of people do. We come from really technical backgrounds and can probably pick it up, but it's hard to know from where I stand what I should be trying to pick up. So we've learned, I guess, a lot about Python basics fine, and we're learning about some of the other packages. I don't know, in each of your jobs, all of them are different. Could you maybe speak to what would be key or really important?
So yeah, right. So I'll paraphrase. So we're learning all these great skills as academics, but in the context of Python, what are the specific packages and pieces that we should be picking up if we are thinking about heading in to the industry side? What's important? Yeah.
Honestly, I would say pick something and like dive in and sort of ignore the rest. I think your OS really matters, like your ability to understand how the operating system works, how a command line works, whether you're on Windows or Mac or Linux. And then most programming languages take differing opinionated approaches to solving the same problems. And certainly certain programming languages are better at others for certain problem sets. But once you get over the hurdle of understanding one language very deeply, I found it's much easier to pick up other ones because the same concepts are there. Sometimes they're expressed a little bit differently. Sometimes it's more elegant to do one thing than it is another in a different language. Something like Python, I think, is a general purpose programming language. When people are talking about being a glue language, that's sort of what they mean, I think, in that it is a great place to start because you could learn anything. You honestly wouldn't go wrong with Ruby or with any number of other general purpose programming languages. It probably has more to do with who you're working with and who your peers are and who you have to go to get help when you do get stuck on various things. But I would say pick something and dive in and be an expert in it and don't worry too much about all of the other choices and options out in the ecosystem right now.
I'd say take a look at what other things you're interested in. So for example, if you are interested in like looking at user interactions and whatnot, you might be working 70% time in the front end and then interacting with the Python database, in the database in the back end, and then the company may be using Python. So that's something somewhere you can start.
Which are you interested in, actually? Are you going the data science route, or? Oh, okay. Then
the answer was she had no idea, just for the record.
Say it again. Then what Grace said then. Okay.
Well, if you really have no idea, it's most important to go to, I think it's really important to go to meetups and like meet other people and talk about what they do on a day-to-day basis. In my meetups, I do two kinds of meetups. One is like have speaker and they present different topics. And then the other kind of meetup is actually a project or hack night. And it's very social. You can, let's say if you're installing Python and have problems, or if you're trying to write a Django app and you have problems and so forth, we'll pair you up with mentors so that you can talk to them about how they do things, what the jobs are like and so forth, so you can get more exposure. And just go out and meet people and find out a little bit more about what you might like. And it's, in terms of finding your first job, it's important to be working with people that you like. Everything else.
So yeah, the question is, do we like Python people? Right. Do you like your peers here? If that's the case, that's a good start.
5 years later, you'll find yourself a specialty.
Yeah, I'm going to go ahead and just say learn Python.
Beyond Python, like NumPy or Matlib or
the built-ins. The built-ins.
All those things. Like
learn the built-ins. The stuff that Python has a lot of stuff. I don't know if we said this, but Python's sort of philosophy is like comes with batteries included. So there's a lot of stuff that comes with Python, and just knowing that internally will help you with everything else, because when you look at any other library, you are going to understand what is going on. It's a very readable language. It's very easy to understand what's going on in other people's packages. If you understand the basics, if you understand the built-ins, which are kind of the only magic stuff that's going on, then it's going to be very simple to sort of take that and run with it. Does that also help? Okay.
So Berian, you recently came to Square, and presumably you were interviewed there. Whatever you can
rigorously.
Tell us, what can you tell us about? And so you are doing Python. What were you asked about your knowledge of Python, and how much were you asked to exercise, and sort of how broad was the scope of the questions they're asking in the context of Python?
Sure. I mean, I think at the end of the day, one wants to demonstrate practical ability. And so some of that involves arcane technical detail because we are in a technical field. However, an ability to demonstrate things end to end is very impressive. And so that's kind of, speaking myself, the kind of thing that I hope I can convey when I am meeting people for the first time or interviewing. Yeah, Square's interview process is extremely enjoyable. I got questions the whole way through about all different things. So whiteboard coding, pairing, talking through question framing, thinking about problems, how to implement them, discussing ideas. So all sorts of things are really interesting. I wanted to circle back to the previous question. I almost held off jumping in, but I actually think that tools for interfacing with data are probably the most important things that folks coming from this background could learn. So pandas is a great start. But maybe you want to think a little more broadly, like if you're going to be interacting with relational databases, then you can use Python to learn a little more about how to interact. You can query those databases, or you can make changes. Or if you're not going to be using relational database structures, there are other tools in data ecosystems that you can learn a lot about. And Python provides a great gateway to interacting with them and learning with them. And that's something that's extremely practical. Without presuming too much of the audience, my guess is that many folks here are from empirical backgrounds, and that data analysis is something that you do in your research, or that you are thinking about doing as you progress further along in your academic careers. And so it's that sort of thing that Python can provide very readily. It's a way to engage with data of all types, small, big, complicated, messy, very clean, and then to extend that knowledge out. It's kind of a gateway language that enables you to start picking up other domains very effectively as well. So I wanted to slip that in.
I want to give a plug on my meetup tomorrow night. We're going to be talking about exactly that. So it's go to meetup.com at SF Python, and basically somebody in the industry working at Heroku right now is going to talk about the magic behind on the database side and how to really look at data, write databases that scale. So come to the meetup tomorrow night.
Fernando had a question here.
So since we're trying to keep the bootcamp completely buzzword compliant, and the buzzword of the day seems to be data science, and you guys are an industry, and that's something where the San Francisco area industry is kind of making big inroads into. What is your perspective of the role a language like Python can play in that world, which is a world, if you go to conferences like Strata, heavily dominated by the Java Hadoop class technologies, a world also where in certain contexts R has a big presence. And so where do you see as that bubble kind of grows before it bursts, as it grows, what kind of role do you kind of see for these technologies in there?
I'll take yeah. So since I do data science, I think I could try to answer this question. So I know that a lot of the big tech companies use Java a lot, and that's, one is for efficiency, and two is it's just what they were using 5 years ago, so they're using it now. However, I think there's a sort of division between people doing data science and people doing like back-end sort of scaling and engineering and stuff like that. So I think there's a pretty big role for Python, maybe not so much on the, not as much on like if you're, working at Yahoo and you need to have this giant infrastructure that's based on Hadoop and all this other stuff. But if you're actually doing data science, I think Python is a really good choice, and R is as well, but once you get out of academia, you're going to all of a sudden realize that people appreciate that you're good at R, but they'd rather that you be good at Python. So, so just know that. Yeah, both is better, right?
I think I want to address why we talk about that big data in Python. So first of all, if you have an application that nobody used, you have no data, and therefore you won't have that problem. But if you actually wrote something that's awesome and people are using it, and you have a lot of transactions, now you really have to figure out how to deal with your data structure, how to shard your data so that you can actually serve the your application as well, right? Nobody wants to have a website or application that responds very slowly. And that's like when you really need to start to think about your whole database. And then now that you have so much data and so many people using it, you start thinking about, I'm Square. I know all these people and how they spend the money and where they spend money on. What can I do with it? There's so many applications that you can do when you have data. And it all starts with like building good businesses that people use. And Ruby can do that as well. Python does that. It's just that this whole ecosystems starts there because people are using the product that you wrote.
I want to sort of take a little bit of a turn, not so far away from Fernando's question, but in this question of big data, talk about parallelism and compute parallelism. You know, the buzzword there is Hadoop, and you know there are these other sort of MapReduce compute paradigms like Disco, which we won't have time to go into in the boot camp, but we'll cover in the data science class this semester. Maybe I could have Ken say a few things about sort of the increasing use of parallelism in industry.
Yeah, and I think this probably ties back to the previous question too, just even about why Python is. Okay, well let me just answer this question. So I guess I'm going to go ahead and refer to what other people were saying. You know, Python's a really great language, but fundamentally, if you're going to be looking at computer science-like jobs, it's very, very important that you understand just concepts and abstractions that are just common across all languages. And so going back to like how we were talking about, you know, Square and interviewing, right? One thing that's great about Python is that it's an excellent language to use in an interview. It's extremely clean, it's extremely concise, but there aren't that many jobs that test directly Python or even Java. You just typically code in whatever language you're familiar with. If you're coding in C, you're going to spend all your time doing a lot of the standard boilerplate, and you're not going to actually be coding the solution, right? So same thing with big data, parallelism, all the concepts transcend programming languages entirely. Now, the difference is, how can you learn about you know, how to do data science, do data analysis on your own, and you know, just so eventually you can apply this at work. If you do it in Python, you can really quickly just use NumPy, SciPy, Matplotlib, and you can quickly just hack it together, see all these things for yourself. If you're doing Java or any other programming language, you can do it. You're just going to spend more time before you get to really the portions that you're trying to do, trying to achieve. So learn the fundamentals. You know, same thing how we were talking about learning Unix. Unix is really the fundamental kind of layer before on top of which all applications written in all languages are written in. So, you know, if we're going to emphasize things outside of Python, it's definitely just getting a broad grasp of knowledge, and that is absolutely at play for big data and parallel computation. And the reason why is because a programming language only has so much importance when it comes to distributed computing. Because when it comes to distributed computing, really it's nodes passing data to nodes. And that's not something a programming language really does. It's something that it passes off the responsibility over to the operating system, to the network interface, to the IPC interface, to the InfiniBand. These other concepts that are just programming language agnostic. So think of Python more as like, it should be one of those important languages in your tool belt that will help you learn about everything very quickly. And then when someone asks you, hey, you know, Python's not the best fit for this, though it's great that you wrote this prototype in Python, you can always write it in some other language.
Can we just have you answer the question that I posed as well, which is that was a great answer to the previous question. But tell me about the growth of PiCloud, you know, and what are the industries that are actually doing parallel computing in the cloud?
Oh, absolutely. You know, it's going to be a lot of industries. So we kind of segmented our own minds into a few different categories. The first, I think, is kind of obvious, is financial institutions. So naturally, you know, they need a lot of compute power. They do a lot of parallel processing. Why? They're doing a lot of risk analysis, options pricing, things that aren't as ideal, but ends up that a lot of PhD students we've noticed go into finance, and they take a lot of the Python experience they developed in academia and bring it over to finance. So that's like one huge industry where we see a lot of parallel computing. And then there's a couple others. Next is kind of academics, universities. And so we have users and research groups from kind of all over, whether it's, you know, medical schools, Harvard's medical school, or statistics departments, geophysicists, computer science and robotics, vision, video processing. Kind of with the increase in data, if you just happen to have data, whether you've self-generated it or these days, you know, the internet just kind of tends to be this infinite source of data for machine learning, natural language processing, you're just going to see a lot of parallelism. Web and mobile companies, of course, right? Everyone there is now dealing with scaling to cases where they have millions of users. How do you, you know, handle that data? Yeah, you could just do what you used to do sequentially, and you could come back and maybe 4 days later, you could do your analysis on the Square transactions for the last week. But realistically, this all needs to be done now in parallel. Now, there's a lot of different abstractions that have been created, though, from MapReduce to things built on top, like Hive, maybe you've heard of, SQL interfaces to map down to MapReduce. Other people are just still using SQL, but doing it in a sharded kind of manner so that it works in a very parallel way. There's so many different things going on. And so it's going to take your own interest and motivation to really figure out what's happening and what's happening in the Python ecosystem versus the other ecosystems. We're going to need to be open to everything. And there's a lot of industrial use cases. And this goes from everything from like energy companies to even like quantum computing companies to energy efficiency companies. It's kind of all over. And so I guess maybe a question you should ask yourself is where you want to be part of this stack. You can be in the stack where you develop the tools that do the parallel computing, or you could be the part of the stack that simply uses the parallel computing constructs that other people have built for you. Now, you might think like, hey, I'm more on the scientific side. There's no real reason why I'd be building the tools. But actually, having people that understand the end application are very, very important to actually building the tools. Because ultimately, the tools are built for a specific application. So it's very, very important to have like your guys' skills at that level, too. Is that better? Okay.
Excellent.
Right now, I have a code that it's in C. It's a computational fluid dynamics code that does high-performance computing.
Is it MPI-based?
No.
Okay.
It's not, and that is my question. I want to make it into a parallel code.
Yeah.
What advice can you give? I mean, comparing C to Python, should I stick with C and do parallel computing and make it a parallel code in C, or should I do it in Python? I have no experience in parallel computing. I just want to.
Yeah.
I'll let Ken repeat the question.
Okay. So the question is, there's a specific application here. It's called CFD, Computational Fluid Dynamics. And he's wondering, well, how do I take it from one machine and now make it run on many, many machines? So unfortunately, your specific use case, CFDs, and I don't have the most kind of knowledge about it. We have customers who use CFDs on our platform. CFDs end up being very, very complex. That's because they're very, very tightly coupled. So as far as I can tell, you have a lot of, the simplest type of parallelism is what we call embarrassingly parallel computation. It's like you want to add two numbers, right? And you have a whole list of these numbers you want to add together. So you can say add two numbers on this machine, two numbers on that machine, two numbers on that machine, and each computer doesn't really need to know about the other computer just to add two numbers. The problem is, in certain applications, CFDs being one of them, you typically have a lot of what we call data transfer. These servers, these nodes will have to talk to each other to a kind of significant degree. So the question to ask yourself probably isn't even what language should you use. You're going to need to use a framework, the most popular one being MPI. It's called the Message Passing Interface. And that's basically an abstraction that makes it very easy for any programming language, traditionally C, but there's also PyMPI or MPI-Py, MPI-Py2, I forget, for Python, which lets you do that communication using the exact same kind of passing interface that they've made. So once again, an example of where it's beyond the language, really. But one key thing is that if you're not too comfortable in C, using MPI is painful. Allocating buffers, moving your data around, it's very painful. And MPI is already complicated enough. So building it in Python will most likely allow you to see, hey, does this work? And assuming that you actually hit the point where you say, hey, it's too slow in Python, you can then go ahead and move it down to C if you wanted to.
And Python
But,
is
yeah.
that significantly slower than C?
It depends on the application, really. It always depends. Like, because we have people who run a lot of computational intensive things on our platform, and you would think they would want to squeeze out every last % of efficiency. But what ends up happening is that the developer's time is just so important these days. Hardware costs in general have plummeted. Access to hardware resources has become much, much easier. So the second that you make your code more parallelizable, you'll find that, hey, you might want to pay for 20 servers instead of 10 because it's going to save you, the developer, so much time. And ultimately, time has become of the utmost importance for developers these days. So it's part of the shift.
Yeah, and what is it that they say? Writing in C is a premature optimization.
Yeah. And don't forget, you're using NumPy and SciPy for most scientific calculations. So you're really just going down to you're going down below the Python interpreter anyway.
Sorry, one follow-up. What about Python?
Python, okay. Does someone here have specific kind of experience? Yeah, okay.
It more or less follows on from what Ken just said in that there's already quite a bit of engagement between Python and C. So if you're on the fence about which way to go, Python definitely provides you a way to explore very quickly what works and what won't work. And then it already has all these engagements with C already that make it possible to make progress more quickly. So there's plenty of opportunities to explore there. And I think potentially Python is covered in the course that Josh runs as a follow-on from the bootcamp as well. So there's many learning opportunities available here as well. Fernando, you had a follow-up? No?
So I had sort of two semi-provocative questions to our panel before we wrap up. Number one is you all come from the Bay Area and are at these awesome, very forward, well, not come from, but you are all at, you come from far away, from very forward-looking companies that are basically, as we've heard, making use of whatever's out there that powers your company, right? If you've got a whole bunch of great Ruby programmers, you're building your company on top of Ruby. If you're doing it on top of Python, that's great because you found some great people early on, and that's sort of the culture that you wind up building. But one of the challenges I would suspect is that, you know, Python is viewed from the rest of the industry, not necessarily sort of the high-tech software industry, as either fairly new, maybe not as robust as some of the very old battle-tested languages, but perhaps more important, there aren't a lot of companies that are kind of behind Python, right? In the same way that there are companies that are behind Hadoop, in the same way that there are companies that are basically monetizing, you know, databases, right? And so I know if I buy an Oracle database, I've got a company called Oracle that's going to be able to help me no matter what problem I have. Aside from PiCloud, there's really just nthought and continuum analytics that are kind of monetizing Python and serving as sort of the support structure. That seems to me kind of problematic from an enterprise perspective. I wonder if you can address, you know, maybe Ken, how you're addressing it, or maybe from the other perspective of companies that are using Python, how much of a concern is it that Python, you know, doesn't have that sort of large and long industry oomph behind it?
Okay, so I think, fortunately, the basic answer is that our platforms actually supports more than just Python. So initially, we launched the product particularly for Python because it was easy for us to prototype, and also it was a good market or interesting market for us because there's a lot of scientific users in academia using Python. So since then, you know, we've and to be fair, really, what kind of decision we came to is that there is no single language at the end of the day that will be able to do everything that everyone will want to program. And there is no single programming language to rule them all. So, we ultimately expanded our platform to support the whole gamut of languages. Is there an issue with there not being someone who backs Python too vehemently? I don't think so. Well, at least maybe not so much in the tech sector. Primarily because I think a lot of the biggest companies use Python. You have a substantial deployment in Google, though naturally they have a lot of Java and C++ as well, but it's kind of known as their top 3 language. You have it used at a lot of other big companies, startups alike, Dropbox, many others. So I don't think there's too much of an issue there. Outside of specifically the Silicon Valley, where I think Python's well accepted, it's true. I think we do get, we get inbound from people saying like, hey, how do we do these non-Python things? I don't think it'll affect the people in this room so much, is basically the answer. But yeah, it's true. Python still has a long way to go to really penetrate all the companies out there. It's not so much that it can't. It's just that in software, there's like the ideal thing, and then there's the thing that everyone else has already been doing for the last 20 years. And a lot of times that momentum is what wins out.
I'm curious to Tim's perspective on that, because Ruby also doesn't have one big company behind it. There's no Oracle behind Ruby, or there's no Microsoft behind Ruby.
Yeah, absolutely. Honestly, I would say I think we're in a phase where like the open source communities are sort of starting to win out in some of those things, and a lot of those tools and languages, people are finding that you can build businesses and then, as GitHub has done, sort of reinvest your employees' time in those open source projects that matter to you. And sort of a different way of going about building some of that core technology than businesses have previously done. But I think so far it's proving to be not only successful and profitable, but a way to really kind of like optimize for employees feeling like they matter in the world, and for people working for your company having an impact larger than just their particular narrow scope or their product, et cetera. And so I think, you know, honestly, when we do a lot of our hiring, we sort of exclusively look at GitHub profiles for developers who come in. And I think it's one of our like best kept secrets is that we don't actually have to do a lot of recruiting for engineers and developers and designers, is because we basically have a website that does it for us. And if you apply for a job at GitHub, we like to go look and see, like, what have you done in the open source community? And even if you've done something private, people will often sort of show us the kind of applications that they've built. We put a lot of weight in being able to take something from an idea to an actual delivered product, because that's really hard to do. And open source really facilitates that for us, because it's a great way to sort of get clout in the industry with things that you're really interested in and stuff that you really want to be involved in. So I think, to me, we're really living on this premise of like software is eating the world, and that's every industry. It doesn't matter whether you're selling DVDs in a store, like that's being replaced by companies who are writing software, or if you're doing banking, that's being replaced by companies who are writing software, or if you're building, you know, universities. I think universities honestly are sort of in danger of this as well, and that like software is taking over the way
cut the feed.
Software is taking over the way stuff is done, and in many cases, sort of open source leads the charge as a part of that, because it's a very different, it's a very open and transparent process. And not to say that it's easy. I think if anybody's actually, like, if you ask Fernando, like, participating in open source is also hard, because it is sort of messy, and it is everybody, and you have a lot of different inputs. Like when we work on projects with Google and Microsoft, they all want to do different things with this open source project, but the result is that you get some better tools, and I think like over time we're going to see that these things are going to have a life of their own. And as these companies grow up and get big, I mean, we're pretty heavily invested in Ruby and in Git at this point. So those technologies, as long as GitHub is a business, we care deeply about those technologies, and they're not going anywhere, right? So.
Yeah, I think that if you're looking at younger companies, the chances are that they are going to have a heavy Ruby or Python code base. Not so much PHP these days, because people are looking at using the best tool for what they are building, right? Now, if you're looking at more enterprise-based companies, stuff that has been around for a long time, I do know that companies like HP and Cisco, they have invested heavily in actually developing Python training courses within the companies, so that the engineers would get to know about these languages. And I mean, they're going to the extent of hiring some core Python developer to go and teach the employees. So it's perhaps there's not a company supporting the movement of Python. However, companies are investing in training and educating the employees in it.
So let me end with just my last question, just go down the line here, starting with Charles. If you could change one thing about Python, what would it be? You can say the global interpreter lock. You can say the GIL, but that's a cop-out. It's the GIL.
That's a cop-out.
Yeah, I know.
Oh, man.
I actually would like to phrase it slightly differently.
Okay, Fernando has a different phraseology.
Which is, where do you see Python's kind of finding limitations in a broader way? Rather than, if you can't think of one specific name, where do you see failure modes based on Python? Or do you have a horror story of either your own or a friend you know, you don't want to name, of a catastrophic failure?
We will accept catastrophic failure with Python, or some boundary condition where you know Python just falls off the cliff.
That's interesting. From a company perspective, I know that with parallelism and speed, that's where, I mean, there is a point at which Python breaks, and we do have to move to other tools. It's a great question. I think personally, the failure of Python is that it's not client side. I can't put it in the browser. That's something that I really wish, like that's tough, right? We are a browser-based company. The tool that we have is in the browser, and we context switch, so we do lose that developer time when we have to move from Python to JavaScript. And if the two were the same, or we were writing the same language on both sides, that would be great. I know that's never going to happen, but there you go.
You skip me for now.
All right, so I get to be the non-Python programmer opinion in the group here. My uneducated outside opinion is that Python tries too much to be all things to all people, and I think in many ways I wouldn't cry the fall of Microsoft Windows or anything like that, but I think trying to be a program that forever, or a programming language that forever supports everything previously and tries to be the glue language that solves every individual problem and tries to make sure that you can write things in C and in R and also bridge to Ruby and also do these kind of things, ultimately sets yourself up to sort of dilute the things that really matter in the language, and lacking any sort of clarity in like, this is where Python's place in the world is, like this is the thing that it's good at. I think there's a danger of it sort of becoming something to everybody but nothing really important to anybody.
Okay, I could think of two things actually. One is sometimes there's different libraries or modules that are become popular and a lot of people contribute to them. And I think one of the things that can go wrong there is people try to make the code so easy to understand and so readable so that anyone can just jump in and participate, that sometimes performance suffers. So, I mean, this is a good thing and a bad thing. So one, a lot of packages are designed so that anyone can just jump in and contribute. But then you sometimes, need somebody to take charge and say, I really want to sort of scrap this thing here and make it a lot more efficient, but you're dealing with all these other people. And so that's maybe one thing that is a good and a bad thing from whatever perspective you're coming at. And then the one other issue is that I don't know how many of you guys have used the nthought distribution, but one problem I've had in the past is on a Mac, sometimes there's issues with getting SciPy and NumPy to work properly. And I don't know if you guys have experienced it. I have. There's never any problems on any sort of Linux-based, or like a Linux distribution. But I've been using nthought, and I've forgotten about what that feels like to have those issues. But I don't know what's going on there. But it'd be nice if that would not happen anymore.
That's a very big problem. I don't know if it's Python specific. I wanted to pick up Tim's point actually, because I don't know if I agree. I think it sounds really compelling what you said, but I don't fully buy it. It's not like a human where you have to choose between being a jack of all trades and being really deep in something. With a language like Python, you can get a whole bunch of people contributing. The number of people who can contribute is effectively unbounded. And so like, then it becomes more of a perception problem. Like if Python isn't seen as a language that can be great across all fronts, then that's because it hasn't been picked up in all the right places. So that was my feeling anyway.
Great, actually I love it. I love it when people disagree. And honestly, I think that it makes for a better conversation even there too. And my perspective is really as a product person, and maybe that sort of the difference of opinions there is that Python doesn't necessarily need to be a product. And I think you look at well-designed products that are sort of thought out through the problems that they're solving and like the needs of, in many ways, like Python isn't the point, like you have some other job to do. And so the best products aren't the ones that have like every possible like piece and knob to twiddle, et cetera. They're the ones that sort of immediately get you to your solution. And I think that would be the danger of having sort of a total blanket jack of all trades, is that something else will come up when I'm an astronomer and I need to visualize my image data, that tweaking this jack of all trades language to like install and work on my OS and do all these things to solve my problem as an astronomer is way more effort than this new thing, which just is focused on me and gets my problem done. So.
Okay, who wants to have the last word while Grace?
I have the last word. I think
Maybe
with well,
Maybe
actually,
the
Ken can have the last word too.
Yeah.
I think that with any languages, you really have to have people using it and contributing to it in order for it to continue to flourish. And there are a lot more Ruby jobs out there than Python jobs. So if people continue to choose to use Ruby as the programming language of choice, and it becomes like a 90%, 10% thing, then there will be less people contributing to the language and make it great. So that could be a potential problem.
Okay, Ken? Well, that's where.
Do you guys use Python 2 or Python 3?
Ooh, we don't do 3.
Yeah, that's probably one of the biggest problems right now. We have this like huge partition forming between Python 2 and 3. Everyone's supposed to move to 3, but is NumPy on 3 yet? It is? Okay.
But it's not. It hasn't been around for a long time.
Yeah, basically there's this whole like issue with the transition, and it doesn't, I don't know, I personally am not too sure exactly what the huge benefits of Python 3 were. They required a lot of the backwards incompatible changes. That's kind of a huge problem. Aside from that, inability to just use multiple cores effectively. So it's not even just a slow part. The slow part you can kind of get around, but you just can't get around the fact that you can't use 2 cores very easily or 4 cores in a machine without spawning up multiple processes. Yeah, really painful. And then last thing for us we always notice is that people installing things on Windows, always a pain. We lose actually a lot of customers. We should track this. When they download and they're coming from a Windows machine, it's just like over. You know, there's a huge drop off. We actually track it between different OSs too: Windows 7, 8, Vista, XP, and I forget, but they're all pretty bad. Yeah.
So with that, I want to thank our panelists for a really stimulating discussion. I was really happy to see the non-virtual pull request from Berian to Tim. Again, thank you all for your time, and thanks to the audience here. I'm sure many of you have questions for our panelists. Let's do that upstairs at the party. So please party with us, Python style.
I also want to mention that I have some Django cheat sheets outside for people that might be interested in that framework.